Well, under that balloon hangs a sonde or a probe, and with that we measure the temperature, pressure and relative humidity of the atmosphere as the balloon rises. There's also a GPS receiver transmitter on board, so we keep track of the position of the balloon, and following the movement we can also measure the wind. It's also a very important input to weather forecast models, so therefore we also sent the results in real time. Directly after each launch we sent the results out by email out on what we call the global trunk, where all the weather services around the world can share all that type of data. So it was immediately available to everyone. We've been taking observations and measurements of basically everything from the surface of the ice through the entire atmosphere. And we're particularly interested in the effects of clouds on the energy balance at the surface. One of the big things that people or scientists are working on is trying to understand what is it that governs the meltback and the freeze up of the perennial sea ice in the Arctic. And there the energy balance at the surface, how much energy comes in and how much energy goes out, is a crucial factor. The first 2 or maybe 2.5 weeks, it's utter and sheer chaos. Things are not working and you don't know how to deal with things, and you run around trying to fix things, and then after 2 or 3 weeks you sort of come into a routine, and when you come to that stage time loses meaning. You can ask someone, what day is it today, and they will say, I don't know. Is it Wednesday? No, maybe it's Saturday. And then the rest of the 7 weeks goes very rapidly. It's like and then you're at the end of the expedition.
Getting to work in a lab as a senior professor, that doesn't happen so much. So the fact that I could go there and spend all my time in the laboratory was really something, because I came up as a lab rat. That's what interested me in the business. So now I could actually be there and actually take part in those measurements all the time was a real thrill for me. The basic analytical tool we used 2 different kinds of lasers in order to get very high precision measurements of CO2 and methane in the atmosphere. And so we did that at 4 different levels on the ship that was continuously measuring. These data that we've collected are the most precise and the most accurate data that have been done in these environments before. So in the data sets themselves will be very valuable. There's a number of interesting possibilities here. What is happening is that permafrost might be interacting with climate as it gets warmer, how is that changing? How is that carbon being moved into the atmosphere? Is it being moved into the atmosphere? Well, I'm hoping to have new questions. I mean, that's what I'm interested in. As a scientist, I'm in the question business. I'm not in the answer business.